Good afternoon, everyone. My name is Agelki Balavanoglu, and I am from the Institute of Construction Management Economics at the Graz University of Technology. Today I will be presenting our research on construction delay and disruption claims assisted through building information modeling. Disrupting events are a common occurrence in construction projects and can have a significant impact on the successful completion of a project. Disputes concerning disrupting events often arise because no party wants to accept the responsibility for the extra cost incurred. The resolution of these kinds of dispute lies within the clear demonstration of entitlement, causation, and quantification of damages. Disruption is defined as an event that leads to the loss of productivity, leading to an increased difficulty of performance and possibly delay. Delay occurs in a project when the contractual completion date is not identical to the actual completion date. Regardless of the classification of the event, both delay and disruption leads to cost overruns and possible claim heads, like for example for labor, material and costs. These are the direct costs, or field and home office overhead cost overruns, the so-called indirect costs. The purpose of our research is to explore building information modeling in assisting delay and disruption analysis, as well as the subsequent preparation of the claim. The following figure provides an overview of the main stages of a research project with the respective research methods and activities. In the first stage of a project, an extensive literature review was conducted concerning the three areas related to the topic. Having determined the state of the art in delay and disruption analysis, construction claims, and building information modeling, the next step of the study is to conclude the empirical study, aiming to identify the status quo in current practice, highlight its shortcomings and potential for improvement. Based on the literature review, a framework was developed describing BIM-based information integration for claim preparation, forming a basis for the development of a graphical user interface prototype that is intended to display all the required information so the forensic analyst can prepare the claim. In the last stage of the project, the prototype will be tested on a case study to validate it and identify possible insufficiencies. The literature review, as well as the expert interviews, quickly highlighted the shortcomings of current practice, identifying as one of the primary challenges that the expert analyst faces in the reconstruction of events as incomplete and unstructured documentation. A quick example of current practice is that when the claim goes to the forensic analyst, he receives many folders with the progress documentation of the whole project, and then he has to manually sort through them and categorize them into topics, and he does that using Excel most of the times. Another problem is that contract documents do not expressively state how an entitlement to an extension of time or time-related compensation is to be proved, nor do they mention an appropriate method for analysis. There are a variety of methods available. For this analysis, some are prospective, where the delaying event is added to the baseline schedule and compared to the unaffected schedule. And retrospective, when the delaying event is removed from the as-built schedule and then compared to the unaffected schedule. more often than not a combination of both prospective and retrospective methods is necessary to validate the results of the analysis. The choice of the analysis methods is greatly influenced by the data that the analyst gets for his claim. These data, for example, come from the daily construction records, where you have the work type, the labor crew size, the productivity rates, and, for example, variation orders that were ordered. And these records may seem clear at the time of documentation, but are often incomprehensible months or even years after the event. Researchers have already identified the potential of building information modeling in dispute prevention and dispute resolution, as well as forensic schedule analysis. Some have only concentrated on visualization and demonstration of the discrepancies between the as-planned and the as-built sequence. And some have outlined the first step of integration of 4D modeling tools into typical schedule analysis. A very important study conducted by David John Gibbs at Loughborough University indicated that there is still a great element of distrust in this kind of representation methods, and therefore in the accuracy of the supporting facts. A framework was developed describing the integration of the necessary information for the preparation of a claim. The figure illustrates the chronological generation of claim-related information throughout the life cycle of a construction project up until the end of the construction phase. A particular focus is placed on the comparison of the as-planned and the as-built schedule with the allocated resources and discrepancies in time and cost. Primary effects are to be analyzed with prospective and retrospective analysis methods and methods to demonstrate damages resulting from disruption. Information generation in complex projects can be extensive, and the challenge is not only for all participants to carry out the obligatory documentation, but also that it is stored systematically for easy retrieval. The next figure depicts in greater detail the process of claim preparation based on contemporaneous information stored in a building information model and the essential delay and disruption documentation reported during the construction phase. The documentation requirements for the impact assessment of delay and disrupting events include accuracy through continuous updates, systematic structure, a high level of detail, and a comprehensive composition. These characteristics have to apply to the following elementary construction progress documentation. The disruption notification, where the contractor notifies the owner that a disrupting or delaying event is occurring on the construction site. The documentation of performance change, according to contract type. It could be, for example, a comparison between the contract drawings and the actual work drawings. A representation in the construction schedule, where the as-planned and the as-built schedule are compared to demonstrate the effects on downstream activities, with a particular emphasis on the critical path. The allocated resources, the daily construction site reports, where you have an overload of data, but you should have specific information because it is one of the most important documents describing the construction site. Photos, preferably with time and date stamps, sometimes even a location. Consultation meeting reports, relevant correspondence. Today, most of the correspondence is conducted via email, but the most important documentation is still delivered in paper form. Change orders and requests for information submittal and response lists. The necessary documentation should describe the condition of the construction site and the activity status at a given point in time, the digitalization of information in a building information model, together with additional information stored in a BCF server, can act as a centralized, structured, object-oriented information retainer for easy retrieval. The following figure shows a mock-up of the graphical user interface. On the left side, we have the as-planned view with the planned model, respective construction schedule, and cost elements. On the right side, we have the as-built view with the respective model, with the highlighted discrepancies in red, that you can easily compare it to the as-planned model, the respective construction schedule and cost elements, and very important is if you have the cost progress in form of a histogram. And on the right side, you have the document view of whatever is relevant to the delay and disruption analysis. The stored information alone is not enough to form a claim. The forensic analysis expert continues to play a very significant role in the analysis of events. The benefits through the implementation of building information modeling, and therefore the new process of information access necessary to support a claim, has aroused a need for a new hybrid forensic analyst. The forensic analyst has to be an expert in the analysis, but also be familiar with the software in order to be able to determine the accuracy of the data stored and be able to pick the relevant ones to support his claim. The next steps of a research project include the completion of the empirical study and identification of the shortcomings of current practice and the potential for improvement. That will form the basis for the further development of the graphical user interface. And in the last stage of the research project, based on the graphical user interface, we will develop a workflow for BIM-based delay and disruption claim preparation. Thank you very much, and I will be happy to answer any questions.